Welcome, friends, again to the playlist on NMD Automator. And this is the fifth video of the playlist, and here we are going to explain you the production stage of the simulation protocol. So the final phase of an MD protocol, where data is collected by sampling the structural characteristics and dynamics of the biomolecular system. Here data is generally used for further analysis, like calculating the RMSD, RMSF, and thus it is called as the production phase. We will use this tab, I'll move on to the main window. We will use this tab to show you how similarly the production tab is populated like the previous tabs and used in the further stage of executing the simulation. So moving on to the significance of the production tab, I mentioned of course, but the significance of the values or the fields over here. See, looking into the tab itself, we are getting a pretty clear image that it is very similar to the equilibration stage. We have Langevin dynamics, temperature, piston decay, piston temperature again. So this is something that we have explained in the previous video, as well as the namings, then the cell basis vectors, then the cell origin. Everything has been explained earlier. The most significant field over here and the value over here is the number of steps. In this stage, the number of steps have been increased because we need to get a detailed trajectory. So we are asking for 1,000 frames, and the trajectory should include all the 1,000 frames. So to get a simulation of 100 nanoseconds, we have kept the value of number of steps as this, as you can see over here, the DCT frequency as this, and the time step as this. So if you calculate the total simulation time, we will get as number of steps into time step. So we will get 100 nanoseconds, and we are desiring to get a 100 nanosecond simulation and 1,000 frames for that simulation. So we need these values. That being said, my friends, we are focusing on the creation. So we will follow the similar steps. We will click on this button called as create production configuration file. It will ask you to save the configuration file in the test directory, the directory that you have chosen. It might change, it can change with the name, so your working directory will be reflected. I'll keep the value, keep the name of the file name, name of the file, the value of the file name same. I'm not going to change it. It will show a default of production.conf. You can change it if you want to. So I'll keep it as it is, and I'll click on save. It will show that it is a success and your simulation parameters are saved, and another pop-up message telling that production file generated successfully. The corresponding messages can be seen over here as well, the CMD interface. And before I move on to the next stage of the NMD Automator, let me show you that where exactly all the files have been saved and how the configuration files look like. So we'll move on to this test folder, and as you can see in this folder, also previously explained, we have the PDB, the PSF, the parameter files, and now the heating, equilibration and production configuration files. We also have the minimization file over here, but for a moment I have kept that aside. So let us look into the heating file first. So like we have followed the protocol, the field values in the tabs, subsequently all the values have been populated in this file. It can be a text file, but it can be It can be any file with an extension like inp, txt, but we have kept it as conf. So it is a text pad and it is a text file. So here it is how it looks. So we have all the values, all the parameters that are necessary for running a simulation. That being shown, moving on to the next stage file, which is the equilibration configuration file. This is how it looks like. I'm sorry, there is a pop-up. Yeah, so this is how it looks like. So it is quite intuitive that whatever the values are kept in the form will be shown, will be reflected in the file when we save it. And finally the production configuration file, and this is how it looks like. So all the fields have been mentioned, like I have explained in the video. Now the main and the most crucial step of the NAMD Automator. We'll click on the next button, and this is what I'm talking about. So this is the Manage Resource tab, the most crucial part of the software, which makes it stand out. Of course, here we identify the available resources to compute the simulation task, create an efficient queuing system that enables sequential execution of the phases in an automated workflow without any human intervention. So let me explain to you each of the fields in this tab. In this field, it is pretty clear that we have to select the version of the NAMD we want to use to run the simulation. So we have kept it as 2 by default, and we have also given you 3 for using. Let me let me give you a disclaimer that 3 is not yet available for the Windows operating system, but we have given you 3 if perchance that we get the new version. You can use that new version and you can use this NAMD Automator by installing the new version as well. So we are thinking of the future. We have given you users the third NAMD version as well, but no worries, if you do not have it, if you have the second version, it will work. The next most important field is the CPU cores. We here need to check how many available cores do we have in our local system. In my local system, in my system personal computer, I have 8 cores. So it is up to you, my friends, whether you want to use all of the cores that are there, or you want to reduce the number of cores and use a limited amount of it. But since I have 8 cores, we will maximize the numbers and we will use 8 cores itself. So another thing, my friend, that I need to also give you a head start to it before you start using this NAMD Automator, that if your system has more than 8 cores, maybe like 16 or 24, or high-end systems can have more than that, if you have it, that number of cores, that exact value, that exact max value will be reflected in this field, not more than that and not less than 0, of course. So what I meant by that is, if you have 24, the maximum value limit over here will be 24, not 25, not more than that. Okay, now the next subsequent field is the selection field. This whole field is kept for selecting the saved configuration files. So we will revert back to the working directory by clicking on the browse button. It will show us that which file to be selected. Here, my friends, I need to first also create a minimization file. Like, I don't have it right now with me, but if we want to, we can create a minimization file, and I have explained it in the earlier videos how to create them and what are the significant parameters over here, what is the meaning of those parameters. So I will create it as of now just to show you how to run the simulation, and without the minimization file the simulation will not initiate. So I will click on this and I will save the minimization file You can refer back to the previous video, the third video, and look into the details of it. I'll skip those part over here right now, and here we are given the messages. Moving on to the last section, which is again the manage resources section. Here I will select the minimization configuration file. So as you can see, once we have selected the path, the complete path of the minimization file is shown. It is a very natural thing to always show the path. It is easier for us to redirect to that path, to that file, and where that file is saved. So again, we will choose the heating configuration, which is the next step. If you can see the placeholder over here, it says that select equilibration file with .cnf, .inp, .txt extension. Like I said earlier, we can use any extensions we want. I have used .cnf, and it is advisable to use .cnf because you never know what errors can be there when you are using some other extension. So we'll select the equilibration configuration file in this step, in this field, and finally the production configuration file in this last field. And my friends, we have completed the tab. Now, why have we selected like I said, the significance of this stage is to automate the whole process. So before I click on this button, configure my simulation, this is basically the run button. Once I'm clicking this, I'm done with the simulation. It will run on its own. The back end of it, how the things have been developed, everything will be explained in can be explained in our papers once it is released. We are not going into that in details, but in the backend section there is a script that is running which automates the entire process. So now my friends, I can click on the configure my simulation button, which is the run button, and as we do it, you can see that it is showing that the current directory for the NAMD is NAMD Automator is the program files, of course, where it will show that path where your NAMD Automator will be installed and kept, and the next line that it shows is running minimization. Now that we have initiated the process, it will run for at least the number of hours it requires to complete the whole task, of course, and based on the number of cores that you have used, you might look into a much faster completion or a slower completion of the whole simulation task. That, my friends, is the end of the NAMD Automator utility and how to use it. I have given you each and every details, the theoretical aspects of each tab, the theoretical aspects of each field in the tab, and the necessary output, necessary values, why we have used it, and how we run the simulation using this Automator application. Finally, the help tab, of course, here it shows us the logo of the university, the name of the application, the version. This is the first version that we have developed, and all thanks to Rohan sir, because he has given me the opportunity to explain to you guys, to you, all of you, of course with regards to the researchers who will be listening to these videos, and it was an immense joy for me to explain to you how the things have worked, how we have congregated everything that was required. If you want to watch the video tutorial after you have downloaded the NAMD Automator application, you can just click on this link, on this word link, and it will redirect you to the YouTube channel where all these videos will be available. Of course, and this video will be there. Excuse me. And if you want to check out the product itself, you can go to the SourceForge.net. SourceForge is the hosting platform where we will be hosting our application, And for any further inquiry, for any further queries that you have while using the Automator app, while understanding the videos, while and if you have any questions that you want to ask, then you are always welcome to reach out to me in this link, in this email. And you're also welcome to reach out to Dr. Rohan, my guide, if you want to, in this email itself. So that's it, my friends. This is where I conclude my video with just one particular thing I always wanted to say, that keep learning and keep growing. Thank you.